Our project is making a mechanical hand that's controlled by muscle movement. So for our LED, we have an LED on this heart sensor that can detect stress gained from these EMFs. So it'll detect the amount of stress in there and it'll light up accordingly to the strength. We have a buzzer here, which will make sound when it's turned on and off, and also when strong movement is detected to close the hand. And this button turns the entire system on and off. And that's the manual input, and the automatic input is the electrode data that we're collecting, which is filtered through this heart sensor, which frequencies are then put through a filter to get accurate muscle data. And you can see all the data here, and when the system is turned on, it will start recording data and it'll start actuating. So here's a demonstration of it in play. Ready?
Now if you try and actuate it again, it won't actually send any signal through.
Yeah, but it'll still light the LED to show that it's still detecting it, but the system won't recognize it. So here's a few more tests. And then turning off. System is now off. Detects nothing. And then system turns on.
Now we knew this was an ambitious project from the beginning, so how exactly did we get here? Well, it definitely wasn't an easy task, but it took a lot of prototyping and a lot of design iterations. First we had to figure out how much power our entire circuit needed, and also how to actuate all the servos at the same time and at the same rate. To achieve this, we used a LiPo battery and a servo driver to actuate 5 servos for each finger. This was our first design, but then we realized that the fingers aren't long enough to actually grab anything. So then we modeled a longer finger and added joints to imitate a realistic grabbing motion, and we were able to test this rotation in SolidWorks.
This is the initial test of our finger mechanism. Just feeding fishing line through, and it closes and opens.
After we had a functional finger, we added a palm and put it all together. We decided to 3D print everything out of TPU because it is a flexible material which makes it less prone to cracking and adds more grip. Now for the first prototype, it wasn't a total failure, but as you can see, the proportions are incorrect. So it's back to the drawing board. We redesigned a new model with a smaller palm, and then 3D printed it again and assembled it together to see what it looked like. And the results this time were much better. We also went through many designs to figure out what was the best way for the fishing line to feed through the palm for the most fluid movement. Next, it was time to test our EMG sensor, or in this case, we actually had an ECG sensor, so to figure out how to extrapolate data and make it so we can actuate the servos.
It detects a signal.
After we figured out how to read and manipulate the data, we were able to successfully connect our circuits and actuate the servos, simply by just moving our arm. That brings us to where we are now, where we have a full working circuit and a working prototype. We learned a lot through this entire process, and we hope to expand on it in the future, maybe making it wearable one day. But for now, I'd say this is a good start to our Iron Man journey.